Students, in this video, we will be looking at another problem where we are going to draw a Bode plot. So here is the problem statement, but it is slightly different because there is a variable k here. This variable k denotes the gain. Okay, so now the gain is given in terms of a variable. Okay, so open loop transfer function has a variable k. Okay, the problem statement is now we have to find the value of k so that the gain margin is 6 dBs. That is the first question, and the second question is you have to find the value of k such that the phase margin is 45 degrees. Okay, so now we have to find the value of k for two subdivisions. Okay, one is gain margin to be 6 dB and another one is phase margin to be 45 degrees. When such problems are given, the first thing the students should do is take just k is equal to 1. Okay, take k is equal to 1. After taking k is equal to 1, you will get g of s without k. So you can continue with the procedures of drawing Bode plot. Okay, so as usual, instead of s, you are going to substitute j omega. And since this is not in the standard format, am I right? You have to take 2 out. When you take 2 out, it becomes 1 plus zero point 0.5 into s, and when you take 8 out, it becomes 1 plus 0.125 into s, so that it becomes it comes to the standard format 1 plus s into t. Okay, so when you're taking 2 and 8 out, it is 8 into 2 16, so 1 by 16 is 0.0625. Okay, so how did you get this g of j omega? uh, that is, first thing is k is equal to 1, second thing is s is equal to j omega, and the third is we have taken 2 and 8 out. Okay, so instead of 16 in the denominator, we have written it as 0.0625. After getting g of j omega, you have to get the corner frequencies. The corner frequencies are 1 by zero point 0.5 and 1 by 0.125. So you got 2 radians per second and 8 radians per second. Now, as usual, you have to get the magnitude expression and phase expression. So magnitude expression, you are familiar with getting magnitude for these terms. J omega 1 plus j 0.5 into omega and this term. Okay. Only new term is this particular fellow. Okay. This particular expression is nothing but it is written in polar format. Okay. This is actually complex number format. Am I right? A plus jb. Here it is written in the polar format, that is r e power j theta. So you know that r is the magnitude and e power j theta. Theta is your phase. So obviously for this term magnitude is 0.0625 and phase is minus 0.2 into omega. So since this minus 0.2 into omega is in radians, to convert that into degrees, I have multiplied it with 180 by pi. Okay. So that this term you will get it in degrees. Other terms are already in degrees. This is 90 degree, and this also you will get tan inverse. Since you apply tan inverse of 0.5 omega, you will get it in degrees. Okay. So everything is in degrees except for this. So I have converted this term into degrees by multiplying by 180 by pi. So these two are the required expressions. Okay, one is magnitude expression and phase expression. Now the student's job is you have to substitute different values of frequencies in radians per second and compute magnitude and phase. This will take quite some time, so please take a calculator and do it. So I have taken some frequencies and substituted the in the magnitude and phase expressions, and I have got the values. Okay. So after computing all the values of magnitude and phase, convert these thing into a semi-log graph sheet. So convert this into semi-log graph sheet. Don't bother about these two graphs. Okay, first don't bother about these two. Just draw it for k is equal to 1. You got a magnitude plot. So magnitude I have written it in the left of y-axis, and for phase degrees are taken in the right hand side. Here you can see it is the degrees. So you have got to draw a phase plot between phi and omega. X-axis is common. X-axis is common for magnitude and phase plot. So left side y we have taken magnitude, and right side it is phase. So now this curve is drawn between this phase and frequency, and this curve, magnitude curve, is drawn between magnitude, and that is a gain, and frequency. Okay, so please, it will take some time. You convert all the points to this similar graph sheet and connect it, you will get a graph. Okay, just draw for k is equal to 1, that is enough. Okay, you need not bother about these two graphs now. So for k is equal to 1, what is the gain margin? You have to compute the gain margin. So for gain margin, you should start with minus 180 degree line. Start from minus 180 degree line, hit the phase plot. This corresponding frequency is called as phase crossover frequency. I think it will go somewhere here. This frequency is called as phase crossover frequency, and gain margin is found at that particular frequency. So from this point, go and hit your magnitude plot. The corresponding magnitude is minus 34 dB. If it hits at minus 34 dB, then the gain margin is 34 dB. Okay. So, but the question is, you have to find the k value so that the gain margin is 6 dB. So what does that mean? I should have a gain margin of 6 dBs. So that now I come and hit it here. Now it is not a minus 6 dB. If it is minus 6 dB, I will get the gain margin as 6 dBs. But instead it is minus 34. So what should I do is, now I should take this point to minus 6 dB. Okay, to minus dB. That means I should shift this graph. Every point I should add how much dBs so that I shift it. Minus 34 to minus 6. How much? 28. So every point here should be shifted upwards by 28 dBs, so that my gain corresponding to phase crossover frequency will be minus 6 dBs. If it is minus 6 dBs, then your gain margin becomes 6 dB, isn't it? So that is what is needed. That is what is needed. So you need not graphically do all these things. Just note down at minus 180 degree at what point it hits the phase plot, and corresponding magnitude, go to the corresponding magnitude, see what is the magnitude. If it is minus 34, but it has to be minus 6 dBs for the gain margin to be 6 dBs. So what should I do for that? I should add 28. Okay, note down that 28 dBs and come back to the calculation part. So what you do is 20 log k is equal to 28. Substitute in this formula 28. How much shifting you have to do? 28 dB shifting you have to do. So just write here 28. Okay, you will get the value of k. Got it? So log k is equal to 28 by 20, and k is equal to 10 power 28 by 20. So you got it as 25.12. Just get it mathematically, the value of k, that is enough. You need not shift the graph here. Actually we have shifted the graph. You need not shift the graph 28 decibels upwards and show it. Okay, these two graphs are not required. Just let us calculate the k value mathematically. Okay, so for calculating a k value mathematically, what we have done, you have to start from minus 180 degrees, hit the phase plot, go to the corresponding magnitude plot, hit it, see the what is the corresponding gain. It is minus 34, but it has to be minus 6 dB, so that my gain margin is 6 dB. So to do that, I should add 28 decibels. Am I right? So take the 28 and substitute it in this formula. 20 log k is equal to 28, and get the value of k. Okay, and the next part is you have to compute the k value such that the phase margin is 45 degree. Okay, phase margin is 45 degree. You know that the phase margin is equal to 180 degree plus 5 gc. Am I right? So in that formula you substitute and find out what is the required 5 gc. The required 5 gc is, when you substitute 45 here, you will get minus 135 degree. When your 5 gc is minus 135 degree, your phase margin will be 45 degree. So what should we do to calculate the k value such that the phase margin is 45 degree? That's what we are going to see here. I will tell you a simple thing. From minus 135 degree Draw a line to phase plot. See, come here. From minus 135 degree line, you please come and hit the phase plot and go up and see what is the magnitude. Go and hit your magnitude from that point and see what is your magnitude. Okay, I think it is around minus 24. Make that point as 0 dB. Okay, if you make that particular point as 0 dB, then your phase margin becomes 45 degree. I repeat it, you start from the required 5 GC, that is minus 135 degree, hit your phase plot, corresponding magnitude you note down, that is minus 24. If you make that point as 0 dB, then your phase margin becomes 45 degrees. Okay, so what is the gain that has to be added for each and every point? It is 24. Am I right? It is 24. Note down that 24. Come here and substitute in this formula. 20 log k is equal to 24. Okay, so if you add 24 to each and every point, then the curve shifts upwards, and the gain margin for shifted curve is going to be 45 degree. Okay, so substitute in this formula, you will get the value of k. You got it as 15.84. Okay, so the shifted graph for k is equal to 15.84, the phase margin will be 45 degrees. Okay, so this is like, though it is slightly a lengthier problem, I just wanted to narrate because you should know that such things are there. Okay, so that's why, though it is lengthier, I have stated all these things. So you need not draw the new two graphs for k is equal to 25.12 and k is equal to 15.84. It is enough if you calculate it mathematically. Okay, how much gain has to be added to the gain plot? If you find that, then it's easy for you to find k value. Both cases, phase margin case as well as gain margin case. Okay, so try this in your semilog graph sheet. So actually your job is only to draw a magnitude plot for k is equal to 1 and phase plot for k is equal to 1. That's enough. Okay. So please do that in a semilog graph sheet and see. Okay.